So in this fairly beefy and long chapter, we finally get to the conversion queue implementation, and we'll be using HOOPS Converter to perform the conversions. So let's get right into it. So let's start by adding a new conversion queue module in the libs folder and adding some boilerplate code to it. Important to note here that the conversion queue and the server are going to be completely separate. One is responsible for uploading files and putting them on the queue, while the other is dealing with the actual cat conversions. Instead of writing all the code for the queue ourselves, we are leveraging an npm module called fast mongoose job queue, which is a very robust and fast job queue implementation. It's built on top of mongoose, so it will be writing to the same database as all our other data related to the conversion objects. After adding fast mongoose job queue to our module, we then instantiate it and creating the queue and provide the name of the collection that we want to use for it. So now let's go ahead and write a function that pulls the job from the conversion queue and processes that job. We're going to call that function simply get conversion job from queue, and the first thing we're going to do is pull a new job from the queue. That's done with this function checkout. The 120 refers to the number of seconds a job has to be acknowledged and or it will be put back on the queue, but we're not going to be worrying about this in this early implementation. So if there are jobs on the queue, we're pulling out the first one, we're getting the files out of storage that we need for the cat conversion, and then we acknowledge that, that the job is done and essentially deleting it from the queue. So let's write that get file from storage function. That function is responsible for basically pulling the conversion data, the original cat file, out of the permanent storage and then making it accessible in a temp directory. So we are obviously using our the function in our storage module, using that same conversion data that we used before. That's where the files are stored. And we're using the item ID. Again, that all came from the database, and the name, and that's how we get to this original cat file. And from there, we're creating a folder in this new temporary directory. That variable we still have to create, and storing the file there. And if it doesn't exist, we make the directory first. So very similar to how we what we've done before in the server module. Now, of course, we need to pull in our storage module, reading and writing from the file system in this case. We need to create this variable for the temporary file directory, and we just hard code something in there. And finally, we have a function that's called on startup, similar to what exists in the server, that provides the actual directory information for the permanent storage. And of course, let's not forget to create that temporary directory for the cat conversion. What we of course also have to do is actually call that function that checks if there's a new item on the conversion queue. It's going to be very straightforward. We're just going to be doing this every second in an interval. And for debugging purposes, let's quickly add some console output here in the job queue every time a new job has been pulled and acknowledged. We also need to expose a function in this module to add a job from a different module. We just calling this function add_job here. We're going to be calling that new function we just created in our server module. So whenever a new file comes in and we're saving it into the database, we're storing it in permanent storage, and we're also putting a new job on this conversion queue that we've just created. And as you can see, what we are actually putting on the queue is the database item of that cut model that has just been uploaded, or at least it's JSON data. Next, just a little bit of housekeeping. So after the uploaded cut model has been put into permanent storage and put on the queue and added to the database, we can now actually delete it from the temporary directory. And fixing a quick typo here, it was actually add_job, not just add. So just one more thing before we can try our new job queue out. In the configuration file, we want to add two more settings, basically saying if the server or the client or the conversion queue runs on a given machine. So we just add these run queue and run server settings here. And based on that, we decide if we're actually running the server and calling the start function on it. Remember, the reason for that is that in a real-world scenario, we're going to have a lot of machines potentially running the conversion queue, but just a few or only one running the actual server that has the upload API. And we need to pull in our conversion queue model into the main app as well. Okay, so now let's try our conversion queue out. We are starting by going back to mongoDB Compass and deleting our previous collection so that we have a clean slate. Let's start our application and upload that cut file again. So it looks like everything has worked as expected. We see in our console the expected message that the item has been processed from the queue, and we can look at our various directories at new queue temp directory where the cut file has been placed. Data is still in permanent storage, and there's nothing in the uploads folder because we just deleted that data. And if we go over to MongoDB, we see now we have two collections. One is the conversion items. There's one item. Data is still pending because we haven't changed anything on that. But there's also this new conversion queue collection, which also has one item which already has been deleted and acknowledged and pulled off the queue. So in the second part of this chapter, we'll be running HOOPS Converter to convert the cut file that has been uploaded and put on the job queue. That means we're going to replace this console output and instead create a new function called HOOPS Converter that's going to receive the payload from the queue. In order to write this function, we're going to be needing two things. One is the directory of where converter is located, which is of course an executable. And then we also need a valid license. And both of those we're going to pull out of the configuration file. So we're simply going to pass those values into those variables in the start function and add them to the configuration. For the converter path, we're simply going to be using converter, and the license we're going to leave blank for now. And after creating this new converter directory in our project, we then copy the correct files over. We simply do that by, from the package, going to the converter bin, Win64 directory on Windows, that is, and copying all the files in that directory into our local folder we just created. As you may have noticed, this course has been developed on a Windows machine, but everything is just as applicable on Linux, just the directory path will be slightly different. Now don't forget to add your converter license, which can either be an evaluation license or the license you get through our support portal. Okay, let's implement that Runconverter function that receives as input information about the uploaded item. We start by defining a directory where the temporary files, essentially the output of the cut conversion, will be stored. Now we need to actually call the converter executable. We could do that with the function called execute file, exec file, which takes the path to the converter executable. Based on the converter path, we add it to the configuration file. And after that, we can pass it the standard HOOPS Communicator configuration options, which you can find in the documentation. Starting, of course, with the license key. And now we're actually adding the path to the input file. Let's not forget the double minus here. Input file, which we assemble essentially from the temp file directory. This is where our file has been placed. Plus the ID, which with the set unique identifier of the converted item, its name, and so on. And I'm copying this here because we need a very similar structure for actually outputting the results. One of them will be an SCS file. That will be the main output, really. That's a converted cut file in the format unique to HOOPS Communicator. But then we also want to generate an image, a PNG in this case. Small aside here, we're creating SCS files, not SCZ, which are meant to be used with the HOOPS Communicator streaming server. But it's really up to you what you are generating and what kind of output you're creating. We're also specifying background color and another setting to make sure that all the attributes are exported to the model. Finally, that function requires a working directory path. So we need to make sure that we specify that as well. Okay, so when the conversion has been completed, or in case it has failed, we get a callback, and we need to obviously act on that callback. In case there was no error, we output whatever converter has spit out, and we're calling another function called conversion complete, which we still have to write. If there has been an error, we're gonna also spit out the result of the error as well as the converter log to the console. And very important, we're also going to be updating the database with the information that there has been some error. We're not just going to put that item back on the queue as had been already acknowledged, because in a lot of cases a cut file might have problems, or converter can't deal with it, and maybe there's not enough memory on that particular server. So we're just going to pass that information back to the database that an error has occurred, and and the user can then decide to reconvert later. And of course we need to clean up our temporary directories as well. And just some making sure that everything is correctly indented, and okay, looks good. Now let's write the conversion complete function. That takes the database item, and essentially what this function is going to do mainly is store the files that have been created with converter, the SCS and the PNG file, in our permanent storage. Basically taking it from the temporary directory and then adding it to the permanent storage at the correct location alongside the original cut model that also is still going to sit there. And we're just doing that twice now. As I said, one time for the SCZ file and another time for the PNG. A little bit of copy and paste, some cleanup, and then we are ready to go. And after the files have been stored, we need to update the database. Now it turns out what we are receiving here is not actually the database item, but just a JSON copy of it. So we need to actually find the appropriate database item once again in our database with that same item ID. And as soon as we have it, we can then update the database and change the status of the cut model. The cut model is now marked as done, and we are saving that information back, and at the end we're cleaning up the directory. We're getting pretty close to the end here. Let's just put the final pieces in place. Obviously we need access to this conversion item, schema, the conversion queue as well. And we need to write that cleanup directory function. And we're using that delete package for that as well, so we need to make sure we have that also included in our module. One little fix, I was updating this item here directly, but I need to actually pull it out of the database first. So I fixed this up here, added a few, cleaned a few up more typos, and then I think we should be ready to go. Let's run the server again and make our REST call and upload the cut file. So if we now switch back to Visual Studio Code, we see in the console that the conversion has been successful. We see that two new files have been created and uploaded to permanent storage, which is a SCS and PNG file. And if you actually click on that PNG file, we can see that, a nice image has been created. Now let's go back to mongoDB Compass and inspect our collections. We have the conversion queue. One file has been acknowledged, and then in our conversion item, oops, there is a little error. It still says pending. It should actually say done because the conversion has completed correctly. So let's go back to our code and see what went wrong. So it turns out we used the wrong name here. Instead of converted, it needs to say conversion state. Let's make that change in both places. Start the server again, and now the result is correct.